All right, so I hope everyone had a good lunch, and now we are ready to continue with the next session. It's a great pleasure to welcome Matej Nedic on stage. He's in fact the main maintainer of the Spring Cloud AWS project, but he's not limited only to that. He's been a contributor to other projects in the Spring ecosystem, like Spring Cloud Config, Spring Data DynamoDB, and others. So, Matej, you have the word.
Thank you. First of all, I would like to thank everyone for coming. Today, we will be exploring how to build Spring applications on AWS. We will be doing this in a friendly way. So before I start, who is actually developing on AWS? Who is hosting? Can you please raise the hand? Okay, perfect. So because of this, let's start with first, what is AWS? This is not an easy task to, explain. So let's go with what we are doing every day on work. We are building some kind of services, right? Some of us might be using databases to store the data. Some might be using caching to have faster response time, maybe to save data as well. Maybe some kind of messaging queues to decouple our services to make some kind of back pressure as well built into it immediately, or some kind of huge file systems to store files. Maybe you're working for government, you have some signed contracts, and so on. Since all of this needs to be hosted somewhere, provisioned, meaning that we would have to have on-premise farms, right? And we would have to host these services, update them, think about, for example, if we are using databases, about read replication, and so on. This is not an easy task. So instead, we can give money to AWS to do this for us. You can host it on AWS RDS. AWS will take care of high availability, about replication, about everything. You only need to know which endpoint to call, basically. Second elephant in the room is Spring. And this is really old framework. It's my favorite Java framework, to be honest. And some of us that are older or have had the pleasure to work, before you had to configure all of your configuration in XML bins. Today, things be evolved, right? And with Spring Boot, you are basically not doing any more of configuration. You're just writing some kind of property files, and everything is configured out of the box. Meaning, if you would use database, you would use Spring Data JPA or JDBC, you would have your data source being already auto-configured, everything would work out of the box. If you use, for example, caching, and you might to use Redis, right? You would have Spring Data Redis. On AWS, you can provision Redis as well. They will take care of everything. But because there are unlimited use cases in life, this means that there are unlimited almost services on AWS. I don't think that one person can name them all. And some services can be only found on AWS. They're proprietary. Because Spring does not have integration, Spring Cloud AWS project was born. Before we continue, I need to give shout out to my colleagues. This project is really old. It predates Spring Boot itself, meaning some people on the roster have changed. Today, it looks something like similar to Tomas Fernandez, Matej Valkoviak, and myself. A little bit about me. My name is Matej Nedic. I'm the lead Java engineer at Infinum, which is Croatian agency. I have been core team member or maintainer, one of the maintainers for Spring Cloud AWS for up to 3 years now. I have contributed to Dapper SDK, Spring Cloud Config. I have contributed to Spring Data project, and so on. Lately, I'm working with Kotlin, Spring, and I'm mostly designing solution on AWS. I really like to tell everything through a storyline. I think it's easiest to get it. So in COVID, we really did a lot of online purchases. Web shops were blooming, for example, Amazon and so on. Now imagine we have some kind of payment service, right? And invoice service. Payment service would process the payment. Once it's processed payment, says, okay, I have done everything, it will call invoice service via HTTP. And this is fine. On AWS, it would look something like this. Payment service, you have something called API gateway. This API gateway, you would expose your APIs, you would do authentication, authorization, and most important, rate limiting. You would have payment service calling API gateway. Your request will be authenticated, authorized, and it will be forwarded to the invoice service. Afterward, invoice service will start generating PDF, whatever it needs. But we have one kind of problem here. What if API gateway invoice service is down? Well, then we need to have something called circuit breaker. We don't want to really spend CPU time and memory time because this means costs. So we don't want to really send the request to invoice service if we know something is down or not working. But now thinking, does payment service really need to know if invoice service has issued the invoice? Well, it really does not, right? It does not care if invoice service is up or not. It does not actually care what will happen with the invoice. And this leads us to our first integration called SQS. It stands for Simple Queue Services, and what is actually it is, it's a just simple queue. Imagine going to the bank, for example. You would come to the line, you would wait for your turn, and once the clerk calls you, you'll step forward. This is, again, fully provisioned service. You just create the queue, and you really don't care anything about it. You just, again, pay. But it's extremely cheap. This is one of the benefits. How this would look? Well, again, our payment service would then send the message to the queue, in our case, AWS SQS. But invoice service will periodically ask queue, does it have any messages? Meaning it's poll-based, it's not push. So invoice service calls, hey, are there any new messages? AWS SQS will say, hey, yeah, I have some, and we will get them and start processing, creating the invoice. This way, we have decoupled our services. They don't care about the response time. We have increased the throughput, but also if the invoice service has some problem or we are doing the upgrade, payment service will keep doing processing the payments and posting them to queue for later processing. Now, to understand a little bit about SQS, because it's important once we will come to the code. Invoice processing service issued the poll from the queue, right? And it gets the message, but something called visibility timeout starts ticking. And this is the period of the time that the message is invisible to another consumer, meaning that you have three services, invoice services scaled horizontally. If first one picked it, the other one won't be able to see it during the visibility timeout period. If you are processing, for example, message and visibility timeout passes, this means that other instances will be able to see this message. This is not something that we want to do because, again, we are wasting money on redoing the work we already done. After we are finished processing the message, we need to acknowledge it, meaning we need to issue call to the queue, say, hey, please delete it, so other consumers cannot see it. How would this look in real life? For example, you have two pods, two instances. First instance will issue the poll, it will get the message. And imagine that we don't have any more messages in the queue. Visibility timeout is starting, it's ticking, and if pod 2 calls to poll, it will get nothing. It will get empty response. When you think about this, building this inside of your framework means that in every library, in every code you write, you need to write polling mechanisms, which is bug prone. You need to write support for acknowledgement. Also, what about visibility? Can you extend it or not? It has a lot of use cases. One important thing about SQS, it has two modes. First is standard, second one is FIFO. FIFO is simple, means first in, first out. And as you can see, message group ID, as shown in top left corner, when you're sending message to the queue, you need to pass the message group ID as well. And this ID basically groups the messages under this ID, and then they're in order once you are processing them. This, of course, means that you're going to have less performance, less throughput than a standard one. Standard queue is basically, they don't guarantee the ordering. They try to order them, but they are not really responsible if they don't order the messages. And because of this, naturally, means that you have higher throughput. You would then poll and get the messages in order, and that is it. Since Spring Cloud AWS tries to be similar to other integrations, maybe you used Kafka, RabbitMQ, this means that you just need to place one annotation to start listening and receiving the messages. And this is called @SQS listener. You want to pass the queue name, and we are going to immediately serialize the object for you. For example, payment, because we are receiving the payment in our invoice processing service. You can then create the PDF, and that is it. One issue happens then, like imagine that you're creating the PDF, and that you notice that you won't have enough time, that visibility timeout will expire. Well, first thing you can do is inject the visibility object inside of your method signature. You can then simply call change to and change it to the amount of seconds you want. In our case, we are extending it to 400 seconds. If you want to change default SQS listener visibility second period, you can just put it inside of annotation. For us, it's 150 seconds. Now, polling is a little bit interesting. It's really complex. I could have a whole conference just talking about how to tune AWS SQS performance, but I will just try to simply explain it. Firstly, you will notice something called max concurrent messages. So these are the number of messages you polled inside of your Spring application and which are not acknowledged yet. Meaning, on the next poll, if you already polled 20 messages, none of them are acknowledged. We do polling in background tasks. Since the 20 messages are already acknowledged, we are not going to do the poll. If you, for example, acknowledge 2 out of these 20 messages, meaning that you have 2 left because 20 minus 18, then we are just going to poll 2 messages. Max messages per poll is how you are basically configuring the message, how many messages you want to poll in the single polling, right? Maximum is 10. This is limited by AWS SQS. 1 is the at least amount that you can do because otherwise it does not make sense. And you can this way configure the number. Poll timeout seconds is curious thing because this is the number of seconds we will wait with the request. Well, actually AWS will keep your requests when it's searching for the messages inside of the SQS queue. This is called long polling. Basically, you're giving them more time to return you 5 messages. Sometimes they may have 3, but they will wait for 20 seconds. Maybe they will return you 5 afterwards. Okay, what about the acknowledgement? Well, if you don't specify anything in an annotation and your method does not throw runtime exception or just ends successfully, we are going to do automatic acknowledgement for you. But if you have runtime exception failing this method that is annotated with an SQS listener, we are just going to not acknowledge it because, right, it does not make sense for us to acknowledge it. Your method has failed. This is why we support manual mode. Meaning, in your annotation, you would put acknowledgement mode to manual, and then you will inject acknowledgement object and just call acknowledge. You will then acknowledge manually if you have use case, for example, that requires this, you can play with yourself. Just remember that you need to do it then on your own. Since Spring Cloud AWS SQS is built on Spring messaging, we are trying to keep aligned with Spring Boot, right? We have built everything upon message object. Message object basically has a payload and headers inside. So if you don't want to inject the payment, etc., you want the headers as well, you can just inject it as a message. If you're interested only in headers, you can inject message headers, and we are going to automatically just give you a hash map with all the headers included. You can just use get method then to get whatever you need. In our case, this will be a trace ID, it can be a JWT token or whatever. Since using AWS SDK client to send messages is not really that easy, we have created SQS template. We configure this out of the box, and behind the scenes, it will use AWS SDK client, which is automatically configured with your credentials, region, whatever it needs. You can just inject it and use the send function and specify your queue name and the object you want serialized. We are then going to serialize your object, send it to the queue, and so on. If you want to send, for example, to a FIFO queue, well, we have function-based support for this. In SQS template, in send method, you're going to have function base. You're going to, for example, as you can see on the line, you can specify message group ID. In my case, it's really stupid because you don't really want to do ordering for company name, but whatever your use case on the job requires to, you specify the ID there. And delay seconds is the option if you don't want message to be visible immediately in the queue. You can specify a certain amount, and this is the amount of time that once the message arrives to the queue, it won't be visible. At queue, you need to specify queue as well, name of it. Notice that FIFO queues need to end with .FIFO, and payload is your normal payload which you want serialized. Of course, sometimes this is not enough, right? Because we have now shipping service. We need to actually send the box to the customer. And now, if we would have like payment service send to this queue, it's not really best practice, right? What if first message was successfully sent to the first queue, to the second queue it is not, right? It kind of brings some kind of transactional issues. This is why there's AWS SNS integration implemented. So SNS is basically, hey, I have an event, it creates the topic, everyone who is interested to this topic subscribes, and they get the message. How this looks in real life now, we refactored our payment service. Payment service would send the message to SNS topic, and then, for example, shipping service needs it to ship the box, invoice service needs it for creating a PDF file for invoice, and maybe statistics service just wants to have statistics. Well, it will use HTTP then to call these endpoints. For example, I don't know how about you, but for me, regularly packages don't come at my address at all because, well, shipping service says I was not home at that time. To avoid this, because this is bad customer experience, we will want to notify customer via phone that their shipment is coming. Well, you can use SNS for this as well. Now, shipping service will create its message. It will say phone number and the message it wants to send. It will pass it to the SNS, and SNS is going to send SMS to the phone. And this way we can say to the customer, hey, your shipment is arriving between 2 and 4 p.m., for example. But if you remember the previous slide, we had an issue because we still had HTTP communication. We don't really want to care about availability of our services. We want to decouple them fully. This pattern is called fanout. So payment service will send the message to SNS topic, and then you will create the queue for each service, meaning shipping service will have its own queue, invoice service will have its own, and so on. SNS will then send the message that you sent previously to each queue, so it's going to replicate it. And afterwards, you will have same polling as you did in previous example. Your services will then poll the messages, they will get it, and they will start processing it. To send the message to topic is extremely simple as well. You will eject SNS template. After this, you can use convert and send method. Basically, you specify name of your topic and your object. We are going to immediately serialize it for you, send it to the topic, and the rest is history. In case you want to send some kind of headers, for example, trace ID, or you maybe want to send JVT because it's going to be HTTP communication, you're going to use message builder. Since again, it's built on Spring messaging, you will use the builder, specify which payload you want. In our case, it will be invoice. You can set, for example, set headers, specify trace ID, JVT. You can chain these set header methods, and that's it. Then after that, you build, and we are going to send it to SNS. When sending SMS, when sending messages to the phone, it's a little bit different. We have different template for this. It's called SNS SMS template. You then, again, have the same function. So you are seeing that everything is same. Everything is built on the same Spring messaging. You would use send, specify the phone number, and the string message you want to send. For example, courier will arrive today between this and this. If you don't want to use queues, if you want your service to be notified via HTTP directly, story becomes a little bit complicated. Firstly, you need to annotate your class with controller. And after this, we created 3 specific annotation, which probably it's kind of hard to understand, but we are extending request mappings for you. So every time you actually create REST controller, you would have REST, and you will have get mappings, post mappings, and so on. Basically, we extended these annotations, and first one is called notification subscription mapping. When you subscribe to the topic, SNS will send subscribe event. You need to confirm this subscription in order to receive the events that are actual messages. This is, so inside of the path, you need to specify the path that you will, when you are creating the topic subscription, you need to give it a path, endpoint, and this endpoint needs to match the path itself. After this, you need to inject notification status, as you see in message signature. You then need just to call status.confirm subscription, and that's it. We are immediately going to send confirmation to SNS. To receive the message, you need to annotate your method with notification message mapping. Again, you need to specify the same path as above. And inside of the method signature, you're going to have @notification subject annotation, which will serialize your headers, and notification message, which will serialize your message, meaning your payload, the main body. Then you can do your logic, depending what you need to do, and that's it. If you want to react on unsubscription event, you need to implement notification unsubscribe confirmation mapping. You will need to use this annotation, actually. You will annotate unsubscribe method with it, and we are going to automatically unsubscribe you. But if you wish to resubscribe because you think it's a mistake, you can then use notification status and call confirm subscription again. It's a rare case. I have not personally seen it, but since it's framework, we need to support every possible use case. Storing files, well, it's an interesting problem because if you run for example, if you run your services in some kind of container service, you cannot save them on pod, really. If you run them on virtual machines, saving them will just be deleted after virtual machine is deleted. IBM has really great support for file systems, and usually when you have on-premise, you are using some kind of their service, at least that was my use case. But on cloud, you will use something called S3. S3 is basically object storage. It's not file system, it's object storage, where key is the name of your file, and the file, well, value is your file in byte array. Now, we had invoices, right? We would create the PDF, but we need to give our customer some kind of access to it. Well, we need to save them somewhere first. In our case, we will create the PDF file, and we will just upload it to S3 bucket under certain name. We can then specify the key and just download the file itself. Most popular use case would be then to present this file to our customers, right? You'll have, for example, your user as a front end. It would actually call API gateway, which you don't see on this picture, but imagine it did not fit. Then it will call invoice service, and invoice service will call S3 bucket to download the object, well, file. It will then download the whole file, pass it to API gateway and to the user. This is not the best use case because we are then downloading the whole byte array firstly in our service, then it goes through API gateway, and it's really not cost effective. We are spending really much money here. Instead, S3 has really cool support called signed URLs. Invoice service can create signed URL with expiration date, and it can pass it to the user. User can then use this URL, for example, to download the invoice, and only the user with this URL can actually download the file. You can also use signed URLs if you want to allow the user to upload the file. For example, if user was uploading directly to S3 bucket, you can create a signed URL, give the user URL, and then they will have rights to write to this for this given key. Now, this is the most common pattern you will use with S3s. Imagine that we are building YouTube, right? We have some kind of video service, and it's uploading chunks of video file to S3 bucket. And now we have some kind of resolution scaling service. As you know, YouTube supports resolutions. You have many resolutions. And we need to scale this chunk down, like it needs to be a lower resolution. If video service would call resolution scaled service directly via HTTP, we have kind of issue because we have, again, transactions. What if storage save upload was successful and HTTP call was not? What if resolution scaling service is not available? And so on. Again, sending it to the queue immediately after brings the same problem. What if queue is not up? What if the sending to the queue fails? What if our service fails abruptly? To solve this, there is something called S3 notifications. Basically, on put object operation or update, well, in our case on upload, S3 bucket can notify certain destination, in our case queue. We can then listen to this queue and go to S3 bucket with the location of the file that changed or was uploaded, get it, scale it, and put it back in the bucket. When you're creating these notifications, you can say, okay, for the certain path, well, certain structure of the key, regex, imagine it like this, please react. For certain paths, don't react. So when the resolution scaling service will actually scale the file and upload it back to the bucket, it won't trigger, again, SNS notification. This is, imagine a message as just saying, hey, this bucket and this location was uploaded. And you can just react to it. And this is the way you actually want to build event-driven systems with S3. To upload the file, it's extremely simple. You would inject S3 template. You can then use upload function and just specify the name of your bucket, the key value, and the input stream. Now, this is coming to be a little bit complicated again. Behind the scenes, we are going to be using in-memory buffering S3 output stream, meaning we will try to fit your file input stream in the memory, and if it's not too big, we will do it in one upload. If it's too big, we are going to do multi-part. For huge files, this is really problematic because you will just crash your application because of it. This is why we support also disk buffering S3 output stream. So if you need to handle big files, when creating, you won't be auto-varying S3 template, you will have to create a bin of your own, and you will mention disk buffering S3 output stream as an option for uploading. This will save it firstly temporarily to the file, and will basically load it bits by bits and be sending it that way. Transfer Manager S3 output stream, we'll talk about it a little bit later, but just remember it exists. If you need to put some kind of metadata to the files, for example, content type, maybe the owner, or you just want to timestamp it when it was created, you can use Object Metadata Builder. You will use same upload function, you will just use metadata builder, content type, metadata, and so on. S3 is usually used for big data lakes. So you will have huge JSON files there for data mining and so on. If you need to store huge files, huge JSONs, you can use a store function. And we are going to basically serialize the JSON object for you into the JSON format. And this way, if you are doing big data, can easily process it. Now to download file, it's relatively simple. You still use the same S3 template. You use function download, you specify your bucket name, your key, and we are going to create you the S3 resource. If you use Spring files, you will know that everything is resolved to the resource. Again, we are aligning ourselves to the Spring Boot. Once you call resource.get input stream, we are actually then going to download your file. S3 resource is just the location. Get input stream is actually starting the download. Then you can read it to the bytes, do whatever you want with this file, right? If you need to read big JSON files, we support the read function. You just, again, specify your bucket name, key, and the class you want us to serialize your object. We talked about signed URLs a lot, and we talked about is the best way to let our front end and let our users download the file. You can use S3 template to create signed URLs. Basically specify the bucket name and key, pattern is the same, and specify duration. Duration depends on the credentials, but usually you will use short-lived credentials. For example, 5 minutes or 10 minutes is enough. If you need to get some kind of file on the startup, for example, you're creating some kind of REST template or web client, and you need to use certificate for authentication. What you can do is use @value, it's familiar annotation. You specify S3 prefix, and then after this bucket in your name of your key, And once you're creating the web client, then you can use, for example, certificate to configure it immediately. This is one of the use cases we support as well. If you require high performances, meaning you want reliability and performances when you're downloading and uploading the objects, you can introduce a dependency called AWS CRT client and S3 transfer manager dependency. Transfer manager input-output buffering stream, if you remember it, is basically only going to be introduced with S3 transfer manager dependency on a path, and it is going to speed up your uploads and downloads really much. So I really recommend for you to use this. If you need client-side encryption, for example, RSA or KMS, I don't care, you can introduce S3 encryption client dependency inside of your code, and we are automatically going to configure that each of your downloads are going to be encrypted / decrypted, depends on your operation. I use this only once in my career, S3 Access plugin. It's when you need to have a fine-grained access control over your files. And usually you will only see that if you have like huge buckets with a lot of customers. Your IAM roles, which protect your bucket, have certain size limits they can achieve. And if you are hitting that limit, you will need to change, you will switch to Access plugin. When I was starting my career, I read a lot of books from clean codes to others, talking about disasters of companies that had configuration mismanagement. They would spread their configuration across the whole organization, and this usually ends up with no one knowing how application actually run. They would not be able to modernize, and basically whoever came could not, they had to end up with the whole rewrites. This is why we have one of the great, at least for me this is my favorite integration, to centralize all of your configurations in one place. You heard probably about Spring Cloud Config, and the issue with Spring Cloud Config is that you have to manage your own services, meaning you have to manage availability of Spring Cloud Config, you will need to host it somewhere, and so on. Instead, you can use S3 bucket. What we do for you, before application context phase even starts, we'll go to S3 bucket, we'll download, for example, application properties, application JSON, YAML, whichever you prefer format most. We are going to download this file, and we are going to enrich your environment for you. Meaning that if you use Spring Data JPA, if you in application properties you have, for example, URL, password, and username, we will download it before context is started, and we are going to configure data source immediately for you. How this looks? Well, for people that use Spring Boot from 2.4 and above, you will use Spring Config import. You will prefix it with AWS S3, specify the bucket name, and the key. In our case, the key is just config properties. We are going to issue the download it, and then enrich your environment variables. If you see it by red, it's a semicolon. You can download more files, and you are splitting the files with red semicolon. You will have bucket name and application YAML as a second file to be downloaded. Because if you don't find the file, we are going to, crash your application. We are going to stop it from reaching application context phase. And if you don't want this, you can mark the prefix with optional. This is the green text. And if you do this, we will just ignore that file does not exist. Since storing really of secrets is not really a great place for S3. You don't want to store your username, you don't want to store your passwords to the S3. AWS has this cool feature service called Secret Manager. This service is fully hosted for you, provisioned again. It does all the decryption for you. And you can safely store secrets there. It's similar like Vault. So we support the same, actually, integration. Before application context phase has started up, we're going to go to Secret Manager, download the secrets, enrich environment, and then you can use them for plenty stuff. For example, imagine that you want to load database secrets. You will specify AWS Secret Manager as a prefix. For example, in our case, it will be pre-prod secrets, database secrets will be the name of the secret. Inside, the value would be some kind of hash map JSON format. For example, it has password and username in it. And it would basically be resolved to, you could, get it by using @value annotation, reference it as a password, or you could use configuration properties, like you manage your properties from application properties which are located in resources. Since this won't actually configure Spring data source, right? We introduced a prefix, this green text. You can prefix your secrets. For example, in our case, it will be Spring data source. So if this is our secret hash map, this is how we will be able to retrieve them inside of our code. Meaning, if you use Spring Data JPA, it will automatically configure data source bean for you. If you don't want to store whole file, for example, you just want to store some kind of parameters because application properties are usually static. They have really rare changes in them. For example, URL will change and things like this, but most of stuff will be static. You can use parameter store. It's basically AWS service for storing the parameters, which you can then use again for example, for URL or whatever you want. It's a key value storage. This is how it looks in AWS console. In our case, we have prod database URL, which is the name of our parameter. We would use, again, Spring config import. It will be just AWS parameter store as prefix. And interesting here thing is that we are loading by the path. We are not loading by the key. So you have /prod, /database/, and everything on this path will be loaded. Meaning in your code, you will access it with like this, @value and URL. Let's spin it a little bit. What if we ended with /prod just? But then in your side of your code, you will access it as a database.url. But I really don't like that you have to create your parameter names in order to resolve them to the Spring, for example, Spring Data JPA standards. So this is why, again, if we have this prod database URL, we have same prefix support. And if you loaded it, if you have the load that ends with database/, in code, you could reference with Spring Data's URL, meaning that you don't have to create your parameter namings based on actually bean required values. If you have, for example, let's say we are kind of building some kind of security endpoint, and it says it's using basic out. You want to rotate these secrets really often, like maybe every 7 days. I have seen applications that are running for 5 or 6 months without crashing, meaning that changing the parameters is not that easy. This is why we support reloading of secrets. We will periodically go, for example, in our case, to Secret Manager, pull the secrets that you have mentioned in Spring config import for you. We will retrieve these secrets, and if we detect the change, you can either choose restart context, you will have small downtime, we will crash down your application context and restart your service. Or if you use refresh, we are just going to swap the beans that are affected. In our case, we had Spring data source. If you change the password, we would create the new bean behind the scenes. All the beans that are using data source will start pointing to this new bean, and the old one we are going to be removing. You can control poll period with Spring Cloud AWS Secret Manager reload period. If you want to use parameter store or S3, you just specify S3, for example, instead of Secret Manager. And now testing. On previous session, we heard that testing should be the first lecture on the university, and I agree. Why is testing important? Well, firstly, it allows us to catch bugs sooner. It also helps us to make our code more maintainable. For example, you have some use cases who, like people, when the newcomers come to these projects, will don't understand anything. And first thing, they're probably going to check tests. And if they create some kind of new use case and they implement it, they might break the old use cases, and this is why tests should catch this. Testing on AWS is not easy because this means that you would have to hit AWS inside of their data center, which you don't want. This is why we have support for test containers. Test containers is this small library which will run Docker containers in your testing, meaning that you can do integration testing with it. You can put in these containers Postgres, Redis, Kafka, whatever is your use case, but we want to put local stack container. Local stack is mocked AWS service, and it basically mocks the usage of real AWS. So if you want to do integration testing, you can do it with local stack. You can see that it's annotated with admin and service connection, meaning that we are going to configure all your S3 templates, SQS template, all the SDK clients we created to point to the local container immediately. Meaning, in your GitLab CI/CD, for example, you can run your integration tests. We will leave the Docker container, and we are going to point to this container for you. Some other supported integrations that I don't have time to talk about today is DynamoDB. We have simple wrapper for DynamoDB client. It removes some kind of boilerplate code where you are resolving the table names. Simple email service integration to send emails easier using Java Mail client. We also support sending of CloudWatch metrics, Spring Modulate, and instance metadata service for fetching the instance metadata if you, for example, are using EC2 virtual machines. And we support GraalVM hints out of the box. Some planned future enhancements we planning to introduce on the project is observability. For example, for SQS will be the first integration we plan to add automatic observability. We are going to propagate the traces and so on. We also plan to do it on SNS next. Event bridge integration. We are planning to support creation of cron tasks and event bridge template. And we are going to plan on supporting Cloud Map. There is already PR for it, but we did not have enough time to check it yet. Since this is a community project, meaning it's not sponsored by AWS or VMware or anyone, it's actually 3 of us doing it in our free time. It wouldn't be possible without everyone who contributed to the project, be that open issue, discussion, create a PR, or just comment on the pull request. And because of that, I would like to thank everyone who contributed to the project. And I hope really that you liked today's presentation, that you maybe learned something else. If you want to check the project, here is the QR code. And if someone has the question, I'm free to answer it now or later. Okay, yes? SNS or? Okay, I will go back to this 1 second. Basically, SNS has inbuilt retry mechanism. It will try up to certain amount of retries. Okay, we are to this here. So if, for example, shipping service is offline, SNS will try to send it. Okay, it cannot achieve it. It will go back. It has internal queue, and it will try up to n times with the backoff policy. For example, every 5 minutes, then next time will be 20 minutes, and so on. And if it fails to send it after n number of times, you can create SQS queue here, and it will go to the letter. And that's it. So it's done by Amazon for you. You don't care. Also, you need to send like successful OK 200. Yes? Oh, sorry, can you repeat, please?
Do you need to have separate applications for every region you want to use AWS in? Because I guess you need different accounts and you need to get different secret for this, right?
In what terms? Like you want to run like...
So you can have one application for, let's say, Europe, right?
Okay.
And then you need to have separate applications with different secrets hosted somewhere else.
Yes. So we would have a multi-region setup. You can have calls to when you're setting AWS SDK client, you need to give it a region. For example, I want this client to call only EU Central 1. If you want to access US, you would have to create another SDK client and make the call. Usually, if you want to run multi-region setup, you would have to replicate secret manager secrets like there and there. Or you will call Europe if latency is okay for you. But usually you will have 2 applications hosted on 2 regions and just have DNS depending on this.
And all the AWS resources you're creating manually, right?
Sorry?
You create the AWS resources manually.
No, you can use CDK, which is, imagine writing Java, and you create, hey, I want S3 bucket, S3.bucket, and you use Java like builder. Or you can use Terraform. Terraform is YAML language, and you can specify which infrastructure you want. For example, S3, RDS, whatever, and it will automatically build for you. Or if you are playing out, you can use AWS console.
Yeah. Okay, thank you.
Yeah, thanks. Yeah.